Good afternoon, everyone. I am Mr. Ish. Thank you for joining me. We're reviewing some differential equation questions in this particular video. We're starting here with this one right here. We have x, y prime, which you know is dy dx, plus 2y is equal to 3x minus 1. We also have that condition f of 2 is always equal to 1. We have to solve this, and how would you go about doing it? The best way to do it and to start is to recognize what form you have. If you were to get rid of that x right there before the y prime, you would have something which would look like this. And it's a linear form, and you know that. So divide everything by x and you'll have y prime plus 2 over x, y is equal to 3 minus 1 over x. And that's exactly what you'll have. Now when you're looking at this, you have a linear form. You can be thinking about an integration factor, which you know is e, and the exponent integral p dx. P here is this 2 over x dx. When you do this, you're getting here e exponent natural log 2 natural log x, which is e ln x square, which by properties of logarithms is just x square. And that right there is your integration factor, which you'll multiply across this equation right here. Dy over dx plus 2 over xy is equal to 3 minus 1 over x. Now you're hitting it with this integration factor, and you can apply it. When you apply it, you're getting x squared dy over dx plus 2xy is equal to 3x squared minus x. Now when you're looking at this, you have to focus right here and see which implicitly derived factor is this coming from, and it's going to be from here and this y, x squared y. If you do the product rule, implicit differentiation, you'll end up with that is equal to 3x squared minus x. You're doing the integral now of both of these sides. These will cancel out, so you're really looking at just x squared y is equal to the antiderivative of this, which is 3x cubed over 3, which is just an x cubed, minus x squared over 2 plus c. You can eliminate that denominator 2 by multiplying everything with it. You'll have 2x squared y is equal to 2x cubed minus x squared plus 2c. So this is what our equation is, or expression or function, but we have to utilize this. F of 2 is equal to 1. So wherever you see x, you'll put 2. Wherever you see y, you'll put 1. So you'll have 2 times 2 squared times 1 is equal to 2 times 2 cubed, because x is equal to 2, y is equal to 1, minus 2 squared plus 2c, and solve for that c. Here you're getting an 8 is equal to, here you're getting a 16 minus 4 plus 2c. Take this on the other side, you'll have a minus 8, and then take the 4 on the other side, plus 4 is equal to 2c, and c is equal to, and you can see it, minus 4 divided by 2 is a minus 2. C is equal to minus 2, and you just plug that right over here, and you rewrite your final answer. It'll be 2x squared y is equal to 2x cubed minus x squared minus 4. And that right there would represent the equation or the function for which this differential equation is true, and the answer should be good. Let's try this. Number 2 question, dy over dx plus 1 over xy equals sine x for the condition f of pi over 2 is equal to 0. When the x value is pi over 2 in terms of the input, we have an output of 0 in terms of the original function. We have to solve this differential equation. How would you go about doing it? Well, recognize right off the bat, we're looking at something like this. Dy over dx plus py is equal to q. It's a linear first order form of differential equation. These are very common, hence you're seeing these in this video. And you would look at this right here, e exponent integral p dx, because there's not much more you can do other than get right into it in terms of determining the integration factor. And this right here is your p value. You'll have e exponent 1 over x dx. When you do this, you're getting e exponent natural log x, which is just equal to x by means of properties of logarithms. You'll multiply this x across. You'll have x times dy over dx plus y over x is equal to sine x. When you multiply it across, you get x dy over dx plus y is equal to x sine x. This item comes here from the implicit differentiation of two variables, which is d over dx and xy. You just have to look at this and this. If you were to open this up using product rule, you'll end up with that. And now what are you going to do? You're going to do the integral of exactly what you see. These will cancel out. You'll just have xy is equal to integral of x sine x dx, for which you have to use the integration by parts technique. U is equal to x, du is equal to dx. V is equal to the integral of sine x dx, which is, as minus cosine x. You have to bring that in terms of uv minus integral v du. xy, what's u? It's x. What's v? It's minus cosine x minus integral v du minus cosine x, du is dx. When you're doing this, you're having xy is equal to minus x cosine x plus integral of cosine x, which is just a sine x, plus c. From here, plug in your inputs. In place of x, you put pi over 2. In place of y, you put 0. When you put 0, you get here a pi over 2 times 0. This will 0 out. You'll have a minus pi over 2 cosine of pi over 2, which is a 0, plus sine of pi over 2 plus c. This zeroes out, this zeroes out, this becomes a 1. C is equal to minus 1, because 1 plus c equals 0, c is equal to minus 1. That minus 1 will make its way right over here. And you can transfer it right over here and affect everything. This here can be your answer if you want to, or you can rewrite it. And allow me to rewrite it in a good way. You've seen how this minus 1 value has come about, but let's push everything on one side. We'll have xy plus x cosine x minus sine x plus 1 equals 0. And this here could be your final equation or answer for which that differential equation holds true and the question has been solved. Let's use this as our last example, review example for this video. We have dy over dx plus y cotan x is equal to cosine x. Condition f of 0 is equal to 0. How do you go about doing this? Recognize here that you have a linear first order differential equation. It has a dy over dx plus py is equal to q format. Here's my p value right over here. You can start here with the integrating factor determination. You know it's always e to the exponent, the p value, which here is e exponent integral of cotan x. What's the integral of cotan x? And you know that to be e to the natural log sine x. And when you know you're doing this, you're getting here a sine x as your integration factor, which you will multiply across. You'll have a sine x and you'll multiply it across this linear equation. A good outcome over here, you'll have a sine x dy over dx plus y cotan x sine x is equal to cosine x and then sine x. This is coming here from a particular value, but you want to simplify this out because it will help you determine what it's coming from. You'll have a sine x dy over dx plus y. This is a cosine over sine, so you're really seeing a cosine x right over here is equal to cosine x sine x. This part comes easily from the implicit differentiation of two items, and they're circled for you. It's y and then sine x. If you do this y product rule, implicit differentiation, you'll end up with that is equal to exactly what you see over here, cosine x sine x. And you bring in the integral signs, this cancels out, so you end up seeing y sine x. Now don't do the integrating by parts technique over here. You don't need to. You can do polynomial substitution or u substitution. If u is equal to sine x, then you know du is equal to cosine x dx, and you can go from there. You'll end up seeing exactly this u du, exactly, because the cosine x will cancel out with that. You'll have y sine x is equal to u square over 2 plus c. What's u over here? It's sine x. You're having y sine x is equal to sine square x plus c over 2. Get rid of this 2. You can do 2y sine x is equal to sine square x plus 2c. I'm getting this denominator, I'm removing it. Now you have to just plug in the values 0 and 0. When you know y is 0, this will 0 out. You know sine of 0 is 0. C is equal to nothing here other than 0. C will be equal to 0. So when you're doing this entire expression right over here, the C will 0 out, and I'll give you exactly what the answer should be. And since we've determined C is equal to 0, what I will do is I'll erase this because you've seen it, and I'll write the final answer right over here. In all instances over here, given that input and the output, C value is 0, so the C goes away. You end up seeing y sine x is equal to sine square x over 2. But this sine x can go on the other side and cancel out with this exponent, and you can literally remove this. So your final answer, or the expression or the equation, is this: y is equal to sine x over 2, and that should be the answer for this differential equation. That would be the function for which that differential equation is 2. Sine x over 2 is equal to y, and that's your answer. And that right there will bring us to the end of this particular video. We looked here at more of the linear form, because linear form and the Bernoulli form are very commonly seen in terms of first order. The homogeneous equations are frequently seen, but not as frequently as what I'm showing you over here. And then the other one where you do separating the variables technique, you see that. The simple direct integration technique, you see that. But these are here primarily the more important ones. So we're reviewing this in this particular video. Thank you for watching. Have a good day.